Clustering models are useful for grouping related items together, such as customers with similar demographics. In this example, we have a dataset containing information about customers who are either interested in or rejected a sales promotion. We want to create a model that will help us to identify the characteristics of customers who are interested in the promotion. First, we need to select the data source for the model. In this case, we'll use a data source called promotions that's based on the Census 01 CSV file that's one of the samples installed with InfiniteInsight. You can follow the same steps using the Census 01 dataset. Next, we need descriptions of the data to correctly identify the characteristics of the variables. We can do this by getting InfiniteInsight to analyze the data and then manually validate the results, or by loading an existing description file. For this example, we'll load a description file. Here we can see the variables from the data source, along with their details. Here we can specify the variables that we want to include in our model. Clustering can be performed without selecting a target variable, but it's recommended to specify a target so the clustering will be focused around a specific business issue. In this case, we care about whether or not customers were interested in the promotion, so we'll choose interested as the target variable. For this example, we'll include all other variables in the model and not include a weight variable. Here we can see an overview of the modeling parameters before generating the model. We can also specify the minimum and maximum number of clusters we'd like to generate. For this example, we'll set 5 as the minimum and 10 as the maximum. The model will automatically determine the optimum number of clusters in this range. Here we can see an overview of the generated model. The predictive power and prediction confidence measures help us to understand the quality of the model. The predictive power of decimal 7474 is a measure of how effectively the model was able to assign customers to clusters based on the available variables. The prediction confidence of decimal 9940 is a measure of how well the model will generalize to a new dataset. In the clusters count area, we can see that InfiniteInsight ran the clustering algorithm for each possible number of clusters in the range we specified, and chose the outcome with the best predictive power and prediction confidence. In this case, the model including 10 clusters produced the best results. First, we'll look at the clusters summary. Here we can see each of the clusters against the number of hours of work per week variable and the interest variable. Next, we'll look at interest against the capital gains variable. Here we can see that the group that was most likely to be interested in the promotion had much higher than average capital gains. Next, we'll look at the category significance charts. Here we can see the relationship between age and interest. Customers between 43 and 57 were most likely to be interested, and those between 19 and 23 were least likely to be interested. Next, we'll look at the relationship between marital status and interest. Here we can see that married customers were much more likely than others to be interested in the promotion. Next, we'll look at the cluster profiles. The Cluster Profiles screen enables us to see the frequency of membership in each cluster and how many members of each cluster were interested in the promotion. We can also compare the distribution of results for any of the available variables in a specific cluster compared to the total population. Here we can see that 5.75% of all customers were assigned to Cluster 1 and that 22.29% of members of Cluster 1 were interested in the promotion. We can also see that all members of Cluster 1 were either a husband or a wife. Next, we'll save our model and then apply it against a new dataset. For this example, we'll save the model to the same location as the data source. Next, we need to enter a name for the saved model. Now we'll apply the model against a new dataset to assign new customers to clusters based on the same criteria as in our original dataset. Now we need to select the new dataset on which we want to apply the model. There are several different options available for how to apply the model against the new dataset. For this example, we'll use the default option, Predicted Value Only. This option will create an output that assigns each customer in the new dataset to a cluster based on the rules defined in the model. Next, we need to enter a name for the output of the model application. Now we'll view the output. In the KC Interested column, we can see the cluster number assigned to each record in the dataset. Note that the Interested column is empty because the customers in the new dataset have not yet been made an offer. The cluster assignments allow us to identify the customer clusters who are most likely to be interested in future promotions. You now know how to perform a cluster analysis in SAP InfiniteInsight. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.